Good morning, dear students. I am Amrita. So, today in this class, we shall discuss the reaction kinetics of hydrogen bromine reaction. Okay. So, before going to study the reaction kinetics of hydrogen bromine reaction, so let us see the formation of hydrogen bromide. So, hydrogen bromide formation takes place by absorbing hydrogen and bromine, both are in gaseous state, which absorbs photon, that is H nu, and to produce hydrogen bromide. So this is the formation of hydrogen bromide. Okay. So here next we shall move on to the reaction kinetics of hydrogen bromine reaction. Okay. In order to study the reaction kinetics, the possible mechanism for the hydrogen bromine reaction are as follows. So, see the first step. In the first step, the bromine is in gaseous state which absorbs photon, that is H nu, with the rate constant K1. So, K1 is the rate constant which is used in the first step, and it will produce two atoms of bromine. So, the first step is called as initiation step. Okay. In the second step, the bromine is combined with the hydrogen with rate constant K2 to give HBr plus H. So this is called as propagation step. In the third step, again hydrogen is combined with the bromine molecule, that is Br2, with rate constant K3 to give HBr plus Br. So observe the second and third step. Both second and third step is called as propagation step. Okay. In the fourth step, hydrogen combined with the hydrogen bromide, that is HBr, with rate constant K4 to give H2 plus Br. So this step is called as retardation step. So why the fourth step is called retardation step means here H plus HBr combine to give H2 plus Br formation takes place. So here HBr consumes a hydrogen atom, hence this step is called as retardation step. Hence the fourth step is called as retardation step. Okay. In the fifth step, bromine combined with the another atom of bromine, so that is Br plus Br with rate constant K5 to give bromine molecule. So these are all the possible mechanism for the reaction kinetics of hydrogen bromine reaction. Okay. So next we shall move on to the rate of formation of hydrogen bromide. So next step, you have to write the equation for the rate of formation of hydrogen bromide by using the mechanism. Okay. By using the mechanism, you have to write the rate of formation of HBr. So see here, so that is given as rate is equal to D into concentration of HBr by dt. Okay. So before going to write the rate of formation of HBr, once again you can see the reaction mechanism. Okay. So this is the reaction mechanism for the um, hydrogen bromine reaction. Okay. So before applying the rate of formation, so find out the hydrogen bromide formation in the mechanism. So in the second, third and fourth step, you can find out the hydrogen bromide formation. Hence, while writing the rate of formation for hydrogen bromide, first consider the second step. In the second step, hydrogen bromide formation takes place. So for that, first write the rate constant, that is K2. So write here D into concentration of HBr by dt, that is equal to K2, and see here Br plus H2, they are present in the reactant side. So first, after writing the rate constant, you have to write the reactant molecule. So that is concentration of Br into concentration of H2 plus, again see the third step. In the third step, HBr present in the reactant side. Hence you have to write plus sign here, and in the third step the rate constant is K3. So write K3 here. Then the reactant molecule are H plus Br2. So H plus Br2 you have to mention in the concentration form, that is plus K3 into concentration of H into concentration of Br2. So this is for the third step. So in the fourth step, observe the hydrogen bromide. So hydrogen bromide is present in the reactant side. So if it is hydrogen bromide present in the reactant side means it absorbs a hydrogen atom. Hence you have to put negative sign is here, minus, and the rate constant is K4. Write K4 as it is into concentration of H into concentration of Br. So this is the equation 1. So this is about the rate of formation of hydrogen bromide. So how do you write the rate of formation of hydrogen bromide means by using the mechanism you have to write the rate of formation. Okay. After writing this one, you have to next you have to put applying the steady state approximation to the concentration of Br. Okay. So for that, find out the formation of Br in the mechanism. So in all the 5 steps, there is a formation of bromine is takes place. So by using these 5 steps, you have to apply the steady state approximation to the bromine molecule. Okay. So d into concentration of Br by dt is equal to, see the first step. In the first step, bromine is in gaseous state which absorbs photon, that is h nu, with rate constant K1 to give 2 atoms of bromine. So for that, while applying the steady state approximation, see the first step, write the rate constant as K1 here. Here the bromine is absorbs a photon h nu, hence you have to write Ia. So here Ia represent the intensity of the light absorbed. So this is about the first step. Next, see the second step. In the second step, find out the bromine. So bromine is present in the reactant side. If it is present in the reactant side, you have to put a negative sign. Okay. So why you have to put negative sign means the reactant bromine is consumed. Hence you have to put negative sign. So minus, then write the rate constant, that is K2. Then the concentration of Br into concentration of H2. Right here. Concentration of Br into concentration of H2. Next, see the third step. In the third step, find out the bromine. Bromine is present in the product side. So for that, write the rate constant. So that is plus K3 into concentration of H into concentration of Br2. Right here. Plus K3 into concentration of H into concentration of Br2. So this is about the third step. Next, see the fourth step. In the fourth step, the bromine is present in the reactant side. Hence, you have to write here positive sign, that is plus. Write the rate constant K4. So write K4 here into concentration of H. Okay, concentration of H into concentration of HBr. Okay, this is the fourth step. In the fifth step, the bromine is present in the product side. Okay, hence you have to put negative sign. Sorry, the bromine is present in the reactant side. Hence you have to put negative sign here, and the rate constant is K5 in the fourth step. So minus K5 into 2 atoms of bromine is present in the reactant side. So hence it will become minus K5 into concentration of Br square is equal to 0. So this is the equation 2. So this equation represents the steady state approximation to the concentration of Br. Okay. In the same way, you have to apply the steady state approximation to the concentration of H. Okay. For the concentration of H also, you have to apply the steady state approximation. Okay. By using these 5 steps, you can apply the steady state approximation to the concentration of H. So write the equation. D into concentration of H by dt is equal to, in the 5 step you can find out the where H is present. Okay. See, in the first step there is no H, that is there is no hydrogen. In the second step there is a hydrogen is present, but hydrogen is present in the reactant side. Okay. So first write the rate constant, that is K2. Right here K2 into concentration of Br into concentration of H2. So right here D into concentration of H by dt is equal to K2 into concentration of Br into concentration of H2. So this is the second step. And find out the bromine atom. So here in third step, the bromine is present in the product side. Okay. For that, if the bromine is present in the product side, and here also in the reactant side also the bromine is present, so you have to consider this one. That's why minus K3, the rate constant is K3 here in the third step. So put minus K3 into concentration of H into concentration of Br2. Minus K3 into concentration of H into concentration of Br2. And minus, here minus, see the fourth step. In the fourth step, the H is present in the reactant side. H is present in the reactant side. Hence you have to put negative sign here, and the rate constant is K4. So write K4 here. First write the concentration of H. Here concentration of H into concentration of HBr. That is equal to 0. So this is called as equation 3. So now you apply the steady state approximation to both concentration of H and as well as concentration of Br. After that, you have to add the equation 2 and 3. So on adding equation 2 and 3, so you will get K1IA minus K5 into concentration of Br square is equal to 0. So this equation when you get means on adding equation 2 and 3. Okay. On adding equation 2 and 3, you will get K1IA minus K5 into concentration of Br2 square is equal to 0. So when you equate this equation to 0, you will get the value of K1A. So the K1IA value is given as K1IA is equal to K5 into concentration of Br square. Okay. So now you have to find out the concentration of Br square. Okay. So take this concentration of Br square outside. So concentration of Br square is equal to K1IA in the denominator, okay, divided by K5. So this is the value of concentration of Br square. So now you have to find the concentration of Br only, not Br square. Concentration of Br, that is equal to K1IA by K5 whole to the power of half. So this is the equation 4. Thanks for watching.